Hello learners, welcome to our 6th lesson. Today we are going to look at the kinetic theory of matter. According to kinetic theory of matter, matter is made up of particles which are in continuous state of motion. It forms the basis of theoretical model of matter. We have solid, liquid, gas and plasma states. When you heat solid, you get liquid. If you continue heating the liquid, you get gas. And when you continue heating gas, it forms a plasma when some particles ionizes. Then when you deionize plasma, you get a gas. Then you continue cooling to get liquid, continue cooling to get a solid, or you freeze. So let us start with the solid state. At this state, particles are closely held together. They can only vibrate within fixed position since there are forces that hold them in this position. When the solid is heated, this one, the kinetic energy of the particles increases and they vibrate vigorously. At a specific temperature, the forces holding particles are weakened enough to allow the particles to change position. As a result, they changes into a liquid state. This temperature is known as the melting point. So solid to liquid, you get the melting point. Then let us look at liquid state. At the liquid state, particles are not close together as they are in solid state. Therefore, liquid particles can move from one position to another, and this explains why liquid does not have definite shape. However, they have definite volume. When liquid is heated, particles move rapidly as the force of attraction or further weakened. The weakening continues until the particles gain enough energy to overcome the force between them. At this point, the liquid boils as some particles break free and enter the gaseous state because they have gained enough energy to move out. The constant temperature at which pure liquids boil is therefore referred as boiling point. Gaseous state. At the gaseous state, the particles are further apart and free to move randomly in all directions. Hence, they do not have definite shape or volume, but occupies the whole space within the container. So if it is contained in a beaker, it will occupy the whole space of that container or the beaker. When a gas is cooled, the particles lose kinetic energy and hence slow down, thus attracting their neighboring particles and move closer to form a liquid by losing this kinetic energy. This process is called condensation, and it occurs at the same temperature as evaporation temperature, which we said can occur at any temperature. When cooling of liquid continues, the kinetic energy of particles further decreases and the liquid solidify. This process is called freezing, and it takes place at the same temperature as melting. Effect of impurities on melting and boiling points of substance. They have some effect on boiling and melting point. Place a mixture of naphthalene and a small amount of camphor in a boiling tube. Here we are using camphor as impurity. Place the boiling tube in the beaker of water and heat as you stir. So we have this setup. We have the clamp, the standard clamp. Then we have the thermometer. We have naphthalene pieces with a small amount of camphor, which we have introduced intentionally for impurity. Then we have water. Then we have wire gauge, we have tripod stand and the source of heat. Here you heat. Temperature is recorded after every half a minute throughout the experiment. Pure naphthalene melts at 80.2 degrees Celsius. If impurities such as camphor are added, naphthalene melts at a temperature lower than the melting point of pure naphthalene, so it will be below 80.2. Impurities therefore lower the melting point of substances. Graphically, you can see this is the melting point of naphthalene, but because it has some impurities, then the range of temperature is below the melting point of pure naphthalene. So you'll find it will melt at a different range from this one to this one. So it is not horizontal as it were in pure naphthalene. Application. Lowering of melting point by impurities is applied in clearing of ice from roads in temperate countries by spreading common salt on the ice. So you add salt to lower the melting point so it clears out fast. Then extraction of metals from the molten compound. Example, calcium chloride is added to rock salt during extraction of sodium from sodium chloride. So this one also saves on energy to melt the calcium chloride or maybe the rock salt. So those are two applications. Effect of impurities on now boiling point of water. We have noted the melting point. The impurities lowers the melting point, but boiling point, let us see. Put distilled water into a boiling tube and heat gently and record the temperature at which it boils. So we have the same setup. We have pure water or impure. Then allow it to cool. Then add sodium chloride as an impurity to the distilled water. Heat, measure and record the temperature at which the solution boils. Now compare the results. The boiling point of pure water at the sea level is 100 degrees Celsius, while impure water starts to boil at temperature above 100 Celsius. The temperature continues to rise as the impure water boils. So it is good to note that at boiling point it boils above 100 degrees Celsius. Thus, the impure water boils at a range of temperature above the boiling point of pure water. Impurities therefore rises the boiling point of a liquid. Note, the heating curve of impure substance has no horizontal position because impure substances melt over a range of temperatures. So pure water, we have a sharp boiling point. Here is horizontal because it is pure. When it is impure, it boils at a range above the pure boiling point of water. So there is a range, so it is not horizontal. Effect of impurities on boiling point, we continue. Criteria of purity. Pure substances melt and boil at a constant temperature or a fixed or specific or particular temperature for a particular substance. So it can be used to know the purity of a substance. Melting and boiling point are used to determine the purity of substances. Melting and boiling point are therefore used for determining purity of substances. When the boiling point or melting point is horizontal, then it means it's a pure substance. Here is the assignment on kinetic theory of matter. We have the questions there. Work them out. Make sure you understand. Refer to the notes as you mark. The answers are provided in the notes section. Thank you and wish you success, and I hope you are enjoying.